Well, hi guys. I hope everyone is doing well. I hope you're getting rest. We're going to go ahead and we're going to just get going. So we're talking about Unit 7, Inferences for Quantitative Data Means. We're going to talk about alpha and statistic tests. We already talked about doing the confidence interval for means, and we already talked about doing the population proportion for significance and the significance test in proportion, so in confidence. So let's get started. All right, so let's go ahead and start with some problems. Checking conditions. Here are the lifetime and hours of 15 deluxe AAA batteries from companies sample below. Check if the conditions for performing the significance test are met. So let's go ahead. First, we have random. No, it says random. You can see that right up top here. It will say the simple random. So all you have to do is restate it in context. Doesn't have to be long. SRS of 15 deluxe AAA batteries. Check. Next, independence. Well, we have to assume some things. We have to assume that my N, which is my population, is greater than or equal to 10 times my sample, which comes out to be 150. I can assume that I can have more than 150 AAA batteries, so I'm good at there. The problem starts with the normal. Well, is 15 greater than 30? No. So therefore, we have to make a graph of some sort. I created a dot plot. You could, however, have done a box plot. You could have done a histogram, a bar graph. It really doesn't matter. It has the same type of information. You got to be able to see whether or not there's any outliers or any strong skewness. Now, dot plots are nice and they're easy. I wouldn't do it if I had a bunch of numbers, but for a small sample set like this, and the numbers weren't too bad, I created a dot plot. Now, I wanted to talk about another type of graph. We talked about in chapter 2, the normal probability. Here is right there. I linked you a place where you can get some practice using your calculator. They actually show you how. And after you're done, I like the dot plot here. I like the normal probability because you can see a nice linear regression here. This is pretty good. All right, you look for the same thing. Does it look linear? Do you have any strong skewness to the left or the down or up? Is there any strange little dots somewhere around there? No. So this would also meet and also say, hey, it could probably be normal. The next, I want to know, could you tell the difference between a Z distribution and a T distribution? Well, let's think about it. Well, Z, you need to have to know what's the standard deviation, where T is you don't know the population of standard deviation. So that's why we're going to use that one. So T looks a slightly different. So let's look at how it looks. If you notice the T1, which is the dotted one in the light blue, 2-degree freedom and 9-degree freedom. If you notice, the standard deviation is a little bit higher, right? Both are symmetric around 0, single peak and bell curve. They do not look any different other than the spread. Now, if you have the T, if you have the T1, if you notice, it can be greater than 3. So that's why it's a little more spread out. Now, if you notice the tails here, see the tails, how spread out they are? So like on this 2, it's gone even further out, where this 9-degree freedom is a little bit better, but it's still going to go further out than the normal one. As the degree of freedoms increases, the T distribution approaches the standard normal. Well, yeah, you can sort of see that. So as more of you get, more samples you get, more samples you get, more samples you get, it actually looks normal. All right, let's go ahead and try this problem. Suppose you want to perform a test of the null hypothesis, where it's equal to 5, and the alternative hypothesis is where it doesn't equal to 5. Well, we want to check it at an alpha level of 0.1 significance. And I want to know if we have a sample size of 37. Now, this is my sample size of 37. And I know from my sample of my 37, my mean is 4.81 and my standard deviation is 3.65. If you notice, nowhere on here does it say anything about your standard deviation. I know my population mean is 5, and I want to prove that it's not 5, but nowhere on here does it say anything about the population standard deviation. So let's go on. Assume that the conditions for carrying out the tests are met for this. Explain why the sample result gives evidence for the alternative. So if you look, here's my alternative one. My mean does not equal 5. And here's my mean of my sample, 4.81. Well, I want to prove my mean doesn't equal 5. Well, did we? Potentially, because I got 4.81. The sample mean is a 4.81, which is not equal to 5, suggests that the null hypothesis is true. All right, now we're going to calculate the standard test. We're going to assume that the conditions are met. We're not going to worry about the conditions, and we're going to get the p-value. This part right here is in your reference material. This is not the formula. If you write down the formula, it needs to be this one. This is just a general one. We use this one for a lot of other stuff too. It doesn't count. All right, so we got a t of inputting our numbers. You can study that. You got a negative 0.317, like I said. Sometimes the T1 is going to be beyond 3, so that's why the tail is a little bit longer. All right, here we go. Here's my tails. All right, so now we look at table B, and we notice that, if you notice, first of all, before we start, is that my degree of freedom is 36, because 37 minus 1 is 36, but I don't have 36 up here, so I have to go to 30. So I find 3.17, which is between these two numbers, and I look up. These numbers on top are for my statistic level, my alpha. On the bottom is for my confidence. They're inside the bell. So let's go ahead and go on. So we're going to get between two numbers. This is not going to be exact. And then, of course, if we go ahead, you can read this. And we got one tail, which is 0.01. We times it by 2. We got the other tail, which is 0.0025, and I times it by 2. So that means my area, my probability is between 0.002 and 0.005. And of course, right here, you can go ahead, hit second bars, and you can input this. Also, right here, right here is a nice little, you can look up the different, how to do it. And if you input it and you multiply by 2, exactly how it is, you need to get a p-value of 0.0031080065. All right, last question for today. The makers of Aspro brand cream want to be sure that their tablets contain the right amount of active ingredient. So they inspect a random sample of 30 tablets from a batch in production. When the production process is working properly, Asprocream tablet contains an average of mean of 320. Now that is my population, milligrams of active ingredient. The amount of active ingredient in 30 tablets has a mean of 319 milligrams and the standard deviation of 3 milligrams. Now, please look. If you notice, they did give you the population mean, but they did not give you the standard deviation mean. All right? So you can often get the population mean. All right. So now we have the null hypothesis, which is 320. You need to list that. My alternative hypothesis is that my mean is not 320. This is my true mean right here. I have to label it. And here is my alpha. All right, let's check conditions. All right, we're going to hurry up here. We're almost done. 30 tablets, check. No problem there. Independent. Can I have more than 300 in my pills? Sure, I can get a bottle with more than 300 pills. So we're fine. Check. Is it 30 is greater than 30? Yep. Check. All right. So let's go ahead and, I already gave this to you. But let's go ahead and look at this. Here's the formula. If you want to do it by hand, And then here is the -2. I already put -2 because -0.183 is right below for it. And I'm like, well, it's a little bit. So put -2. And if I do the area, now this is not equal to, so I have two tails. So I look at the bottom tail and I look at the top tail. And that means my area is going to be between 0.05 and 0.1. Finally, let's go ahead and use a calculator. That's easy. Put that in, times it by 2, 0.070775. That's my p-value. Let's make a conclusion. It has to be written this particular way. You just can't say, oh, because. You have to say all the parts in there because the p-value of 0.075 is greater than my alpha, which is 0.05. We fail to reject my null hypothesis. Therefore, it's not convincing evidence that the true mean of the active ingredient from the batch differs then from 320. So even though I got a sample, I didn't do anything to prove that is true. So I reject my excuse me, 320. So I reject my null hypothesis, and well, goodness gracious, I failed to reject the null hypothesis. It's better. Sorry, guys, it's been a long day. Anyway, that's it for today. You have a couple options. You can go back and watch this video anytime you want. I'm going to leave it up. You can watch the second video. I'll put that on for 9.3b, and then there's a worksheet. I will not be grading the worksheet. The answer keys are attached. However, at some point, I will be sending home quizzes for you to take, and you can send them right back to me, and we'll talk about it, and we'll have a Zoom meeting about how to go about and discuss any problems or concerns or questions we may have. But until then, guys, stay safe, and hopefully I shall see you soon. Bye.